velocity. Without anything to intervene, you're leaving Earth forever going that speed. Except that the moon is going to be there to intervene. We're going to rendezvous with the moon. That's going to slow us down, provide us the base from which to return to Earth. Now to orient a little bit. Behind me and over on my left is the casing in which the lunar module sits at liftoff. So the lunar module, again, is a little box, the ascent stage, bigger box, descent stage, legs. The ascent stage is near the front, the legs are down at this end. 2 hours into translunar flight, here's what happens. The command and service module at the front separate, move out away from the rest of the vehicle in a maneuver called transposition and docking, turn around 180 degrees, the nose of the command module comes back in the direction of the lunar module inside that casing. The casing is jettisoned out to the side, exposing the lunar module, and the nose of the command module docks with the top of the lunar module. Once that docking is secure, then the third stage is jettisoned. Now, does the third stage fall back into the ocean? You should immediately, thank you, sir. You should immediately say, no, it can't. It's going hyperbolic velocity away from the Earth. So what we have to do is deflect its path a little bit, otherwise it's going to follow us just behind us. So we take the residual propellants in the tank, deflect them a little bit to the side, and this thing, instead of going behind the moon, impacts the front surface of the moon. All right, so why do we do that? Because every place that the Apollo astronauts had landed, they had deployed scientific experiments. Among those experiments were seismographic sensing devices. Now we had need of a way to calibrate those devices. So we've got this known mass, known velocity when it strikes, therefore a known momentum. This thing does hit the side of the moon. The moon resonates. Each sensing station picks up a little different signature from that, and then it's up to the seismologist to infer something about the internal core structure from those measurements that he's reading. So that's why the great science experiment. Now, notable on the last 3 flights, and we're passing the placards for 15, 16, 17, was the use of the lunar rover. So there's one big picture directly behind me, or across from me, and several other pictures of the lunar rover in use on those flights. The idea of the lunar rover was this. When you landed, you wanted to land in an empty parking lot on the moon. No obstacles. But that's not where the interesting features were. You wanted to go out to the bases of mountains, the edges of craters, rills, other interesting morphological features from which to return your rock samples. The lunar rover allowed you to go out and away and back a path of about 20 to 25 miles to pick up those more interesting samples. And of course,